Okay, let's evaluate some limits. Evaluating some limits, we're going to first go with the direct substitution method. Okay, this is going to be our first method, direct substitution. So given let's do an example. This is the simplest method ever on limits. So find the limits. The limit of evaluate the limit of for example, we can say x cubed plus 2x squared minus 5x plus 2 as x approaches 2. Find the limit of this, the limit of this. So this is direct substitution. So you only use this method when you try to evaluate the limit and you don't get the indeterminate kind of a solution. Okay, that's the only time this method works. So this is the, from the name, direct substitution. You're going to do your substitution there, 2 squared minus 5, 2 plus a 2 there. This is 8, okay, plus 8 minus 10 plus 2. This is going to give you the limit as what? 8. So that's the limit. Okay, this one is more simple and more direct. Let's do another one. This was our first one. Let's do the second one. For example, limit as x approaches particular number, say 3, 7x squared. What is the limit, okay, of such a function? So like I said, this is direct substitution. Substitute, you should have 7, we have 3 there, squared minus 3, 3 plus 1, okay. Then we have it's going to be 7 times 9 minus 3, and this will be a 4. This will be a 4. Then from there we are going to have, this is 63 minus 3, and we have a 4 there. This is 60 and the 4 outside. This is 6 times 4, 20, like that. So this is the limit. This method is known as direct substitution. It is the simplest method that you can come across on the concept of limits. The next method we should look at is known as factoring and simplification. Factoring and simplification. So for this one, you are in a situation whereby when you substitute your limit, you end up getting an indeterminate answer. This involves factoring and simplification. Factorize and you simplify. So an example on this, we can have example number 1. Find the limit of x, okay, of x squared minus 10x plus 25 over, we can have x squared minus 4x minus 5. Something we should give you some indeterminate solution. So for example, when you try to do a direct substitution with this one, try to do a direct substitution, let's see what happens. You're going to have 5 squared minus 10, 5 plus 25 over 5 squared minus 4, 5 minus 5 there. this is going to give you is a, this is 5 square 25 plus this 25, it will be 50 minus this 50 over here, it will be 0 over this is 25 minus this is a 20 and then negative 5, it will be also 0. This is an indeterminate solution. So what do? You employ another method. So the first method you can think of is factorizing this, the numerator and the denominator, and then try to simplify with their common factors. So factorizing the numerator, let's factorize this. X squared minus 10x plus 25 can be written as x squared minus 5x minus 5x plus 25. Then you can factorize your x there, x minus 5 minus 5, x minus 5. So you end up having x minus 5. This is the factorized form of our given expression on top. Let's now find the factorized form of the other expression, the numerator. We have x squared minus 4x minus 5. This can be written as x squared plus x minus 5x minus 5, x plus 1. You're factorizing your x in the first two terms. Factorize your x, you remain with a 1 there. Factorize what is common, which is negative 5 in the last two terms. Factorize negative 5. Here remain with x, there remain with a 1. Then factorize x plus 1. Okay, you're going to have x plus 1, x minus 5. This is the numerator, the denominator in factored form. So the limit now, the limit as x approaches 5, okay, of this is the numerator, which is given by x minus 5, and the denominator is this x plus 1, x minus 5. Okay, we see that the x minus 5 and the x minus 5 are common factors, so you can divide them out. Okay, you can divide them out, and then you're going to end up with the limit x approaches 5. Okay. Oh no. Okay. The limit as x approaches 5, remain on top, remain with x minus 5, and at the bottom remain with x plus 1. Now from here you see that you can easily put a 5 without getting an indeterminate solution. You can now substitute this directly. You're going to have a 5 minus 5 over 5 plus 1. This is 0 over 6, which is simply equal to a 0. So therefore, the limit of the given function is a 0, which we have here. And that's how you find these limits for function that involves factorization. Let's try to do another example on the same factorization. Let's do another example. So in this example, we're going to have a function which looks like this. Limit, this is 2, okay, as x approaches 3 of x minus 3 over square root of x minus square root of 3. So find the limit. Obviously, when I put a 3 here, I'm going to get root 3 minus root 3 is 0. 0 into any number, it is indeterminate. So what do? You factorize and see if you can simplify something. So look at the numerator. X minus 3 can be written as the square root of x squared minus square root of 3 squared. Okay, you can write it like that. Then using difference of two squares, okay, you can simply write square root of x minus root 3 square root of x plus root limit of this expression, okay, as the value of x goes to 3. So I was saying that when you have x minus 3, you can write your x as the square root of x to the power 2, because remember when you square this, you get a positive number, which is x, a positive number x. When you square the square root of 3, you get positive 3. So you can write this as well as you can write this as this. And then using the difference of two squares identity, you can write these two squares, this is the difference of two squares, in this form. So remember, this is your numerator, so you can write your limit as x approaches 3 as writing this numerator, we have root x minus root 3 root x plus root 3, and everything over square root x minus square root 3. Then obviously from here we know that this and this are the same, so we can divide them out and then remain with the limit as x approaches 3 square root of x plus square root of 3 over, this is 1, obviously, over 1. And then here you can now directly substitute this, and then you're not going to get any indeterminate solution. So substituting this into, let me write it, the limit of x plus root 3. Okay, substituting the 3 directly, you're going to get root 3 plus square root of 3, which is 2 of this square root of 3. And this is the final answer for such a problem. Another interesting problem that we can look at concerning these limits that give an indeterminate solution when you try to directly substitute is this limit. Let's try to find the limit of okay, as x approaches 5 of 1 over x minus 1 over 5 over x minus 5. Obviously, if you try to put a 5 here, you're going to get a 0. And then 0 into anything else, it will be indeterminate. So what do? You first simplify on top. You say, oh, you simplify, make it into a single fraction on top there. You're going to have 5 minus x over 5x over x minus 5. Remember that we have a limit here as x approaches what? 5. Then all this divided by this can be written as the limit as x approaches 5 will be 5 minus x over 5x divided by x minus 5. Okay, you can write this as the limit as x approaches 5 minus x over 5x times 1 over x minus 5. And when you look at this, you can write the numerator, this numerator, in a different way as limit. Look at this magic. Factorize the -1 there, -1, okay, x minus 5 over 5x, and then times 1 over x minus 5. Then you identify this as being equal to this. So you end up with the limit as x approaches 5 of -1 times 1, -1 over 5x. Now you can perform the direct substitution. So you end up with -1 over 5, which is -1 over 25. This is your limit for such a function. Okay. Another interesting example that we can try to look at. Let's find the limit of this expression or this function. So how do you find the limit? So in this case, you're going to, if you try the direct substitution, you're going to get a determinant solution. Okay, so what do? When you see the square roots here, okay, you do what is known as rationalizing. So in this case, we're going to rationalize the numerator. So how do you do that? So get the expression from inside here. Write 25 minus x, okay, minus 5 over x multiplied by, rationalizing this, you're going to write the same thing here, root of 25 minus x, only with an opposite sign there. So you want to write this in such a way that you end up getting a difference of 2 squares for the numerator, because you are rationalizing the numerator. Okay, so multiply this, all these times this, you're going to get the root of 25 minus x minus 5, the square root of 25 minus x minus 5, over to be x times everything else here, to be x times everything else down there. This should be a plus 5 there. Then obviously from this, you see this is a difference of 2 squares. So you can use that identity to write, or you can expand manually if you want, to write the square root of 25 minus x squared minus 5 squared. That's how difference of 2 squares works. Then maintain your denominator here just the way it is, square root of 25 minus x plus 5. Okay, then evaluating the numerator, what do you get? This will be just 25 minus x minus 5 squared is 25 over x root of 25 minus x plus 5. Okay, and solving this one further, this 25 minus 25, it is 0, so you're going to remain with negative x over x in bracket square root of 25 minus x plus 5. From here you can see that this x and this x can be divided out and remain with negative 1 over square root of 25 minus x plus 5. So this is just you have just simplified. So going back to the original question, okay, which requires us to find the limit. So going back to the original question, which requires us to find the limit, we should have that limit as x approaches 0 of negative 1 over square root of 25 minus x plus 5. Now you can do direct substitution and it will work. So putting 0 where there is x, going to have minus 1 square root of 25 minus 0 plus 5. Minus 1 over square root of 25 is 5 plus 5 minus 1 over 10. That is your desired limit. Okay, that is your desired limit for such kind of problems. Thank you.